You know, we like to think we've got a pretty good handle on our universe, but the cosmos always has another surprise up its sleeve. So today, we're going to take a grand tour of some of the most astonishing, truly mind-bending discoveries that are rewriting everything we thought we knew. Let's dive in. All right, first up, what if I told you we've had the color of an entire planet wrong for decades? Yeah, that iconic, deep royal blue Neptune we all saw in our textbooks. Turns out it's not real. The image you see on the right, that is much closer to what you'd actually see. So how on earth did this happen, and what else are we getting wrong? So here's the plan. We're going to start by fixing that cosmic color palette. Then we'll do a rapid-fire tour of the strangest secrets right here in our solar system. After that, we're going big, hunting for alien megastructures, bending the rules of space and time, and finally, we'll tackle a question that changes everything. What does it even mean to be alive? Okay, so let's get to the bottom of this Neptune mystery. It's actually a fantastic story of how science works, how it corrects itself. Okay, so here's the deal. When the Voyager 2 spacecraft flew past Neptune way back in 1989, scientists intentionally cranked up the color. They deepened those blue tones to make all the faint clouds and storms pop, to make them easier to study. And look, it was great for the science at the time, but it accidentally created this misconception that lasted for more than 30 years. Now, using modern telescopes and new analysis, they've gone back and recalibrated those old images. And what they found is Neptune's true color. A much paler, kind of greenish blue, which, get this, is almost identical to its neighbor Uranus. And you know what? That whole Neptune color thing, it's really just the tip of the iceberg. It turns out our own cosmic backyard is filled with all kinds of bizarre secrets, just hiding in plain sight. You think you know our planetary neighbors? Well, think again. They are full of surprises. Take Uranus, for example. The planet is basically knocked over on its side as it goes around the sun. Its axis is tilted by a staggering 98 degrees. The leading theory is that it got slammed by an Earth-sized object billions of years ago. Just try to imagine what that means. You get the most extreme seasons you can possibly imagine. Each pole gets 42 straight years of sunlight, followed by 42 straight years of complete freezing darkness. Wild. And then you've got Saturn. At its North Pole, there's one of the greatest weather mysteries in the whole solar system, a massive, perfectly geometric storm in the shape of a hexagon. No, this isn't some trick of the light. It's a real six-sided jet stream. It's so big you could fit 2 Earths inside it, and it's just been there, totally stable for decades. Scientists have some ideas about why it's there, but for now, it's just this beautiful, bizarre riddle we haven't quite cracked yet. And hey, don't forget our own moon. It holds some incredible secrets too. We usually picture it as just this gray, dusty ball, right? Well, its south pole has some of the coldest places in the entire solar system. We're talking temperatures plunging to minus 382 degrees Fahrenheit. There are craters there that are in permanent shadow. They have never seen sunlight. And that treacherous frozen landscape is exactly where India's Chandrayaan-3 mission just made its historic landing. And that rover didn't just manage to survive the insane cold, it made a huge discovery. For the very first time, it directly detected sulfur in the lunar soil near the pole. Now, that might not sound like a huge deal, but it's a really key chemical clue that helps scientists piece together the moon's volcanic and geological history. So all these discoveries right here at home just go to show how much there is still to learn. But what about out there, beyond our solar system? The big question, right? Are we alone? Well, one way to find out is to stop looking for little green men and start looking for their technology, specifically the massive engineering projects of a truly advanced civilization. This is where the idea of a Dyson sphere comes in. And seriously, this is a mind-blowing concept. Just imagine a civilization that's gotten so advanced that its home planet just can't provide enough power anymore. So what's the next logical step? Well, you build a megastructure around your entire star to capture nearly all of its energy. It's the ultimate power plant. Okay, but how in the world would we even find something like that? The theory is actually pretty elegant. See, the sphere itself would block a lot of the star's normal light, making it look dim to us. But, and here's the key, all that energy it's capturing has to go somewhere. It creates waste heat, and that waste heat would radiate out into space as infrared light. So we're not looking for the structure itself, we're looking for its heat signature, a star that looks weirdly dim but glows like crazy in the infrared.
And get this isn't just sci-fi speculation. There's a real project called Hephaestus that is actively digging through massive amounts of telescope data, hunting for exactly this kind of heat signature. And they've already found 7 potential candidates. These are M-dwarf stars that seem to be putting out way too much infrared radiation. We don't know for sure what they are yet, but the follow-up work is just getting started.
All right, for this next bit, we're going to the very edge of what we think is possible. We're diving into the world of theoretical physics, where the rules of the universe get, well, they get wonderfully weird.
Okay, so we all know about black holes, right? The ultimate cosmic vacuum cleaners. They're a real, confirmed prediction of Einstein's theories. These spots where gravity is so strong that once you're in, there's no coming out. But what if those same equations also allowed for the exact opposite?
Say hello to the white hole. Now, mathematically, they are a totally valid solution to Einstein's equations. They're the mirror image of a black hole, a region of space-time you can't enter, and from which matter and energy are just explosively gushing out. Now, to be clear, we have zero evidence they actually exist. But some physicists have even theorized that the Big Bang itself could have been a kind of white hole.
And what about the holy grail of sci-fi, faster than light travel? We all know Einstein said nothing with mass can hit light speed. End of story, right? Well, maybe not. The Alcubierre warp drive concept is this brilliant theoretical loophole. The trick is, the ship itself isn't actually moving through space. Instead, you create a bubble of space-time around the ship, and you move the space, contracting it in front and expanding it behind. There's a perfect analogy for this. Think of it like a surfboard on a wave in the ocean. The surfboard isn't really moving through the water, it's just riding the wave. The wave is what's moving. In this case, the ship is the surfboard, and the wave is the ocean of space-time itself, carrying it along. You could potentially travel faster than light without ever breaking the local speed limit.
Now, the original catch, and it was a big one, was that this would take an impossible amount of energy. We're talking the mass energy of the entire observable universe. But and this is what's so cool, physicists have kept working on it. They've been refining the model, and new theories suggest if you just tweak the shape of that work bubble, you could bring the energy needed down to the mass of just 3 suns. I mean, that's still a colossal amount of energy, but it's a huge leap from literally impossible to just wildly, wildly difficult. All right, for our final stop on this tour, we're coming back to one of the biggest questions there is. When we go looking for life on other worlds, what are we actually looking for? How do we define it? A fascinating new idea called assembly theory might just give us a universal answer.
The core idea here is all about measuring how complex a molecule is. It does this with something called an assembly index, which is basically just the shortest number of steps it takes to build that molecule from scratch. Think of it like a Lego set. A simple water molecule is like snapping 2 bricks together. It has a low index. But a complex protein, that's like a 10,000-piece Lego Death Star. It has a very, very high index.
And here is why that matters. This is the big takeaway. If you find a molecule with a really high assembly index, it's just incredibly unlikely that it could have formed randomly. The odds are astronomically low. That level of complexity is a powerful sign, a biosignature, that it had to have been built by a process, like life and evolution. And this could be a universal way to search for life, one that doesn't depend on it looking anything like us. We just have to look for that signature of complexity. So there you have it, from the true colors of planets in our own backyard to hunting for alien megastructures and rethinking what life even is, our understanding of the universe is changing all the time. What's amazing is that each new discovery doesn't just give us an answer, it gives us better, way more interesting questions to ask. And it always leaves us with that biggest question of all, the one that keeps us looking up at the stars. Are we alone? Thanks for joining me.